Hey there, Math 126 fans. Going to talk about center of mass, just do a quick practical video. I do have videos on explanation of where things come from, but this is going to be about what you need to know. In terms of the final exam, you would want this on your note sheet and know how to plug things into it and compute. And that's really it. So really what you need to be, you'll be given a function, which represents the density, and you'll be given a region. And then you do have, unfortunately, if they ask you for the full center of mass, then you do have a few computations to do. You have to compute that integral, you have to compute the other integral, and then you have to compute this integral, which is the same for both of these. That bottom integral represents the total mass. Okay, so we either give you the density outright or we describe it to you in words. All right, so let me pull up what could happen. Here are the scariest looking things that could happen. And often we give you the density outright, but let's say we didn't. And someone says, in a lot of these questions, it makes sense to say something's getting heavier or lighter in a certain way. So if we say proportional to, it means it's some constant. And if it's proportional to the distance from the y-axis, your distance from the y-axis is what x is. Distance to the x-axis is this. If it's your distance to the origin, then it's a constant times this. If it's the square of the distance to origin, it'd be the square of that. If it's inversely proportional, it'd be 1 over that. That's it. So this question, they said proportional to your distance from the origin, so that density is a constant times your distance to the origin. And the region is this. 1 to 2. It says that. So you'd have 3 integrals to compute. You do the integral from 0 to pi over 2 of 1 to 2, and you would do x times your density. Now the density is actually k, if I do it in polar, times r. So the density is k times r. And then you'd have x here, but x would be r cosine of theta. And then you'd have r d theta. And you would just run through and compute that. Separately, you would do same bounds, 0 to pi over 2, 1 to 2, and then we would do just the density if we were computing the bottom. So it's going to be, the density we said was k times r, and then you'd have r d theta, and that would be this. So this would be what I was calling number 1 here, the thing that goes here. This would be number 3, the thing that goes there and there. So if you divide those two things, that's x bar. And finally, you'd compute one more thing. So 0 to pi over 2, the integral from 1 to 2, and you'd have y times the density. Y is r sine of theta, k times r, r d theta. You'd compute that. That's 2. So let's finish this by looking at a homework question. So again, I want this section to be quick for you. You do need to be ready for it in the final, but I'm trying to show you that it's not really something to be feared. It is a computational exercise, but let's read this. So it says the density is inversely proportional to the distance from the origin. So that's saying this is our density function, k over the distance to the origin, which in polar would be k over r. That's the thing we're integrating, but we have to do a few things. So we have this region. The region is between these two circles together with the portions of the x-axis that join them. So circle of radius 3, circle of radius 5. There we go. There's my region. And so your job in that homework question, now a little thing that's kind of interesting is this region is completely symmetric and the density is completely symmetric. So I have a strong suspicion that this is 0. Now it has to be both things are symmetric, not just the region. but I think both are. So that saves me a little bit of work. So I think all I need to compute is y bar, and that will require that I compute two things. So I'm going to do this in polar. It's 0 to pi, it's 3 to 5, and it's going to be y, which is r sine of theta, times the density, which is k over r d theta. So that's what these pieces are. This is the density. This is dA. So you would compute that, whatever that is. So you now have this job of computing this. Pi from 3 to 5. The k can come all the way out. You have sine of theta r d theta. And then you would also need to compute the total mass, which is the exact same thing but without the y. So it would be k over r d theta. This is k, the integral from 0 to pi, the integral from 3 to 5 of 1 dr d theta. That's going to be pretty darn quick. When you are done, you'll divide those two numbers, which means the k will cancel, and that will be y bar. So I have 0, comma, and then whatever number I get out of this. So again, that's not something to fear on a final. It is nice to see that double integrals are used for things other than just volume. I hope that demystifies things. All right.